Well, as the title says, this will be the first episode where we're going to be working on the town of Warrenville, which is the smaller of the two towns on the layout. And this will cover quite a number of episodes because I have quite a bit to do in Warrenville, and they won't all be contiguous because some of the things I'll come back and do later as I work on ideas about track arrangement and fit buildings and everything. But to get ready to do Warrenville, I've been very busy. I've put in all the risers and the cleats for the sub-road bed for Warrenville all the way around to where I had brought the main line in one of our more recent episodes. I showed where the main line had stopped, and that is going to be the west side of Warrenville and Warrenville Junction, and it's where the branch line up to the lumber mill operation branches off from the main line. And there's going to be some grain elevators and agribusiness associated industries in Warrenville too, which will be some switching for the locals, which will also run up the branch line. To put this in, what did I put in the risers and then set them up vertically and leveled them and leveled the cleats. I'm using my 6-foot masonry level here. I ran level along, cross leveled diagonally, made sure everything was lined up. Also used my 2-foot level to make sure everything was level. Got that all set in. That was a bit of work, but taking time, being patient, being careful is very important with this. And also I have run the power bus for the DCC for Warrenville and for the main line, which is going off to the east to the larger town, which by the way now is, I've settled on a name, Carlsbad, spelled with a K. There is a Carlsbad, California, spelled with a C, but mine's with a K, and Kathy's idea too, that was good. So I'm giving the German spelling of Carlsbad. And all the power buses are in. The SB5, and I'll show a graphic on this, the DB5 dumb booster is over on a shelf on the other side of the layout, and that's going to provide power to Warrenville Junction, Warrenville, the main line into Carlsbad, and the Carlsbad Yard and industrial tracks. So that's about half of the trackage of the layout. The smart booster handles the other half, but the smart booster sends the commands also to the dumb booster. The dumb booster is over there, and I put in 3 DCC Specialties smart circuit breakers here. And one of the things, some folks have asked me how I would do things differently, critiquing what I've done and what I've learned. And of course, as you do one of these projects, you're always figuring, oh, I'm going to change this when I do this or that. And one of the things that I came up with is these digital circuit breakers give light indications of what's going on. Now, for the staging yard, the 3 digital circuit breakers over there in the main line are set back closer onto the benchwork. But I discovered that I'd really like to be able to see them better. So if you can imagine, this is towards the front of the benchwork. There's going to be a fascia that goes along here, a trim to hide the benchwork from people so it looks a little more finished. But you'll be able to see underneath it, you'll be able to see the smart circuit breakers. And that's a good indication. You can tell where something is, if something is not right, you can look at the indicators, and that's one thing I decided to do differently. As I said, the wire is in, it's all been twisted, it's all ready for the installation of feeders to the track. Now, the sub-road bed in Warrenville and Warrenville Junction is going to be made up of these panels of 3/4 inch birch plywood. This is a 2 by 8 foot section. Here's another roughly 2 by 8 foot section, which has got a curve in it up here because it fits up snug against the backdrop. And then these 3 gore sections here, which take the sub-road bed around the curve and a filler for some angular difference. So the next thing I'm going to be doing is putting these sub-road bed pieces down and then getting ready to lay the track, some of the track in Warrenville. And the first thing I'll do after I put the sub-road bed down is paint it with Kills undercoat, which seals up the plywood, so because there's going to be some moisture with the scenery, I really don't want that getting into the plywood. Also, it provides a good tooth, a good base for the scenery materials, and it's nice and bright and white, and it allows me to draw with a sharp pencil very good center lines for the roadbed and the track. And so that'll be the next major step in here, is mounting this and getting it ready. And once I start putting track in, I'll be dropping the feeders to the DCC power bus. Now, regarding the track, my prime objective is to get to the point right now, the near-term objective, where I can run a train clear around the layout. So when it comes to Warrenville and Carlsbad, the main thing I'm going to be doing right now is pressing on, laying the main line track, kind of the way they built the Union Pacific and Southern Pacific towards each other back 150 years ago. But that's my emphasis, so I'm going to be playing around a lot with Warrenville once I get the main line track, and I know where I want that to go. But once I've done that, then I'm going to start filling in the side yard tracks and everything, because I've got a number of ideas I want to experiment with, and I just want to, I've already built some of the buildings, and I've got ground plan layouts for others. And I'm going to be constantly moving them around in Warrenville to see where I find something that aesthetically I like. And that goes back to something I said earlier, that you do a lot of planning on your model railroad, but when it comes down to actually building it and seeing it at one-to-one scale, when you're down here in it, all of a sudden you realize, oh wait a minute, this would look a little bit better done that way or this way. So there's the plan and there's as built. And yeah, you're about 90% with the plan, but there's always this 10 or 15% of, I think I want to do it a little differently, like as I said with the smart circuit breakers. So that's where we are right now. Tomorrow I hope to have the sub road bed mounted and done, and then I will be painting it with kills, give it a day to dry well with that, and then start to lay out track center lines, and we'll be off and running on another stretch of main line. Well, welcome back. It's been guess a couple months since I've done the last episode. Doesn't mean I haven't been busy. In fact, my apologies for the delay in getting this episode posted, but I discovered something as I was working on this. As I'm working my way around the layout, I'm going through progressive stages of construction. So the things I was explaining in early episodes, like building the sub road bed and laying track and doing some wiring things, I have to do all that before I move on to the next phase. So I had a lot of work to get done before I could show new stuff that I'm doing. But having said that, we now have all of the track in the town of Warrenville, excuse me, play on words where I live, but in the town of Warrenville, and had a lot that I've been doing here, and I'm going to go through a whole bunch of these things following on in this video. Some of the video I shot months ago as I was starting this, so there'll be a little bit of a flashback on some of the parts of the video, but put it all together in a coherent whole. But just to show you overall what I've done so far is notice Warrenville is all complete in terms of the track and the wiring, and I've mounted fascia board on here to dress up the front of the layout a little bit, and I'll be talking about how I did that. And I've got structures positioned. I knew pretty much where I wanted to put the structures, but once I got the track down and started playing around with fine-tuning adjustments and stuff, I did make some moves. So there's a number of industries in Warrenville, as you'd expect for an agricultural area. And considering it's a farming area, there's several grain elevators. There's this large concrete grain elevator that I built from scratch a number of years ago. And then this is a kit-built ranching and lumber supply company. And this is another grain elevator over here. And then if you can see further down this way, there's over against the backdrop there's a propane distribution center, or propane fuel, and another set of grain storage bins, grain elevators. So there's 3 spots for covered hopper cars for grain. And then over there in front of the grain storage bins, there's the Union Pacific station that I built back last year, which is going to be the station in Warrenville. And I have a bunch of things to talk about in terms of track laying and some of the things I've done. You'll also notice there's a backdrop, and I'll talk about how I did that. So we're going to cover a number of things in this episode, and kind of how-to stuff. So hopefully it'll be interesting to you, and you'll see how we do this. So it's starting to look more and more like a layout, and all the wiring is in, all the track is operational. I've test run trains through here, and everything works fine. I've even got some things to talk about, a product I discovered that really helps with the performance of your trains, and this is something I highly recommend. So with that, I'm going to shut off the camera and reposition some things, and then start to do some of the conversations that I've got about some of the things I've been doing. One of the products that I've started using that I had read about several years ago, and it really made an improvement in the performance of my locomotives and the DCC in general. And that's something that, years ago we used to use brass rail for track HO. I'm old enough to remember brass track, and it was a real pain because of the speed at which brass oxidizes, and the oxidation is non-conductive, so you were always cleaning track. And plus, it really didn't look like steel, it looked like brass, which was rather unrealistic. Starting, I guess, 40 or more years ago, we did a quick move into nickel-silver rail, which looks like steel. Aside from the fact it is less conductive than brass, somewhat, which I mentioned in a prior episode, where you're well advised to drop a power lead to each section of rail to ensure good connectivity. You can't depend on rail joiners to bridge the electrical gap between sections of rail, but if you do with that as a matter of practice, you'll have good connectivity. But it still oxidizes. The oxidation is not as much an impediment to the transmission of electricity as the old oxidation on brass rail was, but it becomes a real problem when you have a faint signal command going across the rails too for your receiver. So you want to make sure you have a good conductive surface. About a year ago, I was reading on a blog, and someone in model railroading with an electronics background mentioned a product. It's made by a company, Craig Laboratories, and it's called Deoxit DL100, and it comes in these 25 milliliter bottles with a fine point applicator tip, or the bottle with almost like a nail polish bottle with brush on tip and a cap. You don't need much of it, but what you do is just take a little stretch of track and put some of this, and I use this for the points where I have to get some into where it's not very accessible. I'll use the brush and run a little bead along each rail for a stretch of 6-8 inches, and then the wheels on the locomotive and the cars are actually distributed along the track for quite a length. And what it does is eliminates the oxidation and puts in a barrier that prevents it for extended periods. So you don't have to do this all that often. I've heard once every 6 months or a year or whatever. And this is a really good product. The instant I used it on this layout, I remembered I'd bought it, dug around in my tools for it, got it out, and in the storage yard where I was experiencing some problems with how the trains were running, I put this down and I noticed an immediate 1,000% improvement. No stalling, no hiccups on commands. Everything ran beautifully the way you'd want DCC to run. It's not inexpensive. You can get it at Amazon Prime. I think I bought 2 of these bottles for $15 each, and I think this bottle with the applicator was like $18. But you can see you use a very, very little amount of it, and it really does a wonderful job. One of these other things I'd mention in conjunction with this is a lot of the cars, freight cars you buy today, or the railroad cars you buy today, come with metal wheels, but there are still some out there that come with plastic wheels on the axles, and I've got some of them. And one of the things that I do before I ever put a car on the layout is if it has plastic wheels, I swap them out with metal wheel sets. Plastic wheels are terrible. They're like brass track. Okay, they're a throwback to earlier years in the hobby, and all they do, they're dirt magnets. Okay, they for some reason they accumulate dirt. They distribute dirt on the track. They create electrical contact problems, and so one of the best things you can do is switch over to metal wheel sets. So having said that, when I put some of this on the rail, maybe every 10 feet or so, just a fine bead of it, you don't need much, and the locomotive runs over it, the cars behind it just distribute it along the rail, and it does a beautiful job. So the product is called Deoxit DL100, and it's by Craig Laboratories. You can find it on Amazon Prime, and of course all the outfits like Mouser and DigiKey, they all carry it too, all the electronic supply houses. But these are the 2 forms I'd recommend for our use. So give it a try. I think you'll notice it makes a real improvement on your layout, and that whether you're running line L or HO or anything in between and in scale, it's really worth trying. Okay, after putting in the supporting risers and cleats for the bench work, the first thing I had to do in building the town of Warrenton was to set up the DCC for this side of the layout, and to run the wiring buses that are going to go under Warrenton, or Warrenville, excuse me, and also to run a bus up to part of the main line that's going to be served up in this direction at the turn-back curve. Now this is where my DCC system starts to grow, because you'll see in this first graphic that there's a little shelf that's put in under here on the other side of the layout, and it's holding what's called a dumb booster. It's a North Coast Engineering DB5, and that's one of the things when you go with a certain manufacturer of digital command control, the standards are that different manufacturers' decoder receivers that go into locomotives and with accessories, they work across the board. They're built to a standard. They'll work with anybody's DCC system. But when you get in the main architecture of the system, the command stations, the boosters, and this kind of thing, you generally have to stay with one manufacturer. So you pick the manufacturer you like and you stay with their system. And I did this with North Coast Engineering because of the expandability of their basic power cab system that I started with. The power cab system provides a little less than 2 amps, but when you add a smart booster, SB3A or SB5, to that, the smart booster takes over the command station processes from the handheld power cab unit. So then you have a 5 amp capacity system. And when you're building a layout as large as this, with the runs of power bus and the amount of activity going on, you need some more power, and the DB5 is connected by a 4-lead command cable to the SB3 or SB5, and it's a dumb booster. It doesn't have the built-in ability to become a command station, but it acts as a slave and additional power to the SB3 or SB5. So that's what I've done here. There's a DB5 over here connected to the SB5 that's located over here in the original location where I showed it. And as the graphic shows, it's on a shelf on the other side of the layout. There's also a couple 12-volt power supplies for some of my turnout motors that I'll explain in a bit. But the other thing I put in here, and you can see it peeking out from underneath the fascia here, which I wanted it visible because it has indicators when there's a short. They'll get her to more digital DCC specialties, smart circuit breakers. And they're basically set up, the two on the left side of the board are set up to handle the area of Warrenville itself. The main line trackage through Warrenville is on one, and all of the yard trackage and sidings and everything are all on the other one. So if I have a piece of equipment that derails to short here, it won't shut everything else down. And the one on the right is for the main line segment that goes between Warrenville and the main town of Carlsbad, which is again off that way, which I'm going to be building. And so that's what's set up under here, and that was the first thing I had to get done before I put down the basic sub-road bed for the town of Warrenville. And then we're going to move on and talk about some other things that I did. Well, as I was explaining in the previous segment, I'm not going to go back and restate how I've done things in prior episodes, but to get to this point, and where we are now in the chronology, I had put down the sub-road bed, and on that I painted it with kills to provide a good smooth white surface to draw us track center lines on. And I went ahead and drew the track center lines and put down the road bed. And you may notice over here in the yard tracks, the road bed is lower. Now I use standard cork road bed for the main line of the passing siding. But in railroad practice, the secondary tracks, yard tracks, industry tracks, are always set lower than the main line. And this is a safety precaution that's gone back well over 100 years. Essentially, that if the brakes disengage on a car that's parked or spotted on a siding, and the brake shoes come off of the wheels, the cars can tend to drift. They roll very easily. They're very heavy, but they roll very easily. And on even a minor grade, they can start rolling. And though this doesn't happen very often or seldom, unless usually it's a human mistake, somebody forgot to sufficiently tighten the handbrake on the cars, or some vandals came in and started screwing around with it. What this does is the incline to get up to the main line prevents the car from rolling up onto the main line. And I wanted to have that look on my model railroad, and with these mainline tracks here, and then there are 2 yard tracks and a runaround track that gets to the industries or the switching locations on the town of Warrenville. I used actually 1/16 inch contact paper cork that has self-adhesive on the back to make the lower roadbed, and then I built the incline from the main line down to that. It's a very slight incline, so it looks very realistic. And also the ballasting in the yard and on the branch line on the runaround track is not going to look highly manicured like it does on the main line with a nice angle of repose and slope. But these tracks tend to be receive lower attention because they don't bear the speed of traffic that really creates the wear on the roadbed, and so it's going to look a little more. There's going to be some weeds growing up in some various places, and this is something that even on the best railroads, this is just track that does not receive as high a level of attention and maintenance because basically it doesn't need it. So with that, I had all the track down and all the wiring is in, and I've gone over that in prior episodes about the DCC wiring, and it's all carrying forward the same very organized approach that I'm using. And so what I started to do here, the next thing I'd like to talk about is switch machines, or point motors for our British friends, your continental friends. Something needs to be stated. On the main line that I'm modeling here, and in the era that I'm modeling, the late 1980s, 1990s, as is today, mainline trackage is centrally dispatched. Now, what I mean by that the actual control of trains comes from a centralized dispatching location that can often be 1,000 miles away or more. For the Union Pacific, this is Omaha, Nebraska, and the centralized dispatching for the entire railroad all the way to the west coast and everything all originates in Omaha. And because of that, the switches on main lines that cross over mainline tracks that intersect on the mainline tracks from secondary lines are all thrown by the dispatchers in the control centers. And these switches are thrown usually by straight electric or electro-pneumatic, electro-hydraulic switch machines. Because in moving the movable portions of the rails, there's a lot of weight there. I mean, it requires a pretty good push to get these things to shift. And so you need something like an electro-pneumatic, electro-hydraulic switch machine, which they've been using for over 100 years. Now these switches also have manual overrides. They can be manually thrown, but that's only when lockout permission is given by central dispatching, because there can be reasons to locally throw them. But these switch machines or point motors that are used on mainline tracks, the big difference between them and what we often see on model train or toy train layouts is there the turnouts snap to the other position. You'll hear the snap like I have in my storage track switches, and it's all a very positive thing and everything, but that doesn't happen on the railroad. You can see these things move, and in fact occasionally people have gotten in trouble, usually trespassers and walking along railroad tracks, that they've actually stepped down at the instant when a switch has been activated and the point rails close on their foot, trapping them to the track. That's not a place you want to be, but it has happened. But I wanted to replicate the appearance of an electro-pneumatic switch machine. And a brief note for the tracks on the yards, the switches on the yards and the industry tracks, as in real practice on American railroads, those are all manually thrown. And because of that, they have manual ground throws, they're called, and I'll talk a little more later about how I'm emulating that. But fortunately, there's a company called Circuitron that makes a lot of model railroad products, and one of the things they make is something called the Tortoise slow motion switch machine. And I got a number of these, as I can show in the graphic that I'm going to put up on the screen here, that I ordered them. You can get them in boxes of a dozen. Really. But these are very nice switch machines. They have a gear train in here and a small DC motor, 12 volt DC motor. The motor can actually run anywhere from 9 to 12 volts. I run mine at 9 volts because it helps reduce any noise, and it also slows down the action to a point where I like it. And the motor moves this arm to one side or the other, and there's a lever or a rod that comes up through, that pokes up through the layout and engages the center of the throw bar or the switch, and you'll see in a little bit how that works. And when the polarity is changed, the motor moves this arm over, moves the lever in the opposite direction because there's a fulcrum point up here, and it does a really nice smooth movement of the switch. Now the motor stays energized, but because it's a very, very efficient motor, a small motor, it only draws, it's basically a stall motor. It gets to the other side and stalls. But its stall current is only 30 milliamps, which is 31 thousandths of an amp, which is basically next to nothing. And so you can have a whole bunch of these with stalled in one side of the other position, and they're really not drawing much current at all. I've got small 9-volt power supplies running them, so, and I showed on the slide the other episode, the other segment of this episode, previous one. I'm going to go through a number of graphics here. The first graphic shows, and I talked a little bit about this in a prior episode, how I did the actual roadbed blocks for the turnouts. Is instead of using cork, which, as I mentioned, if you're making your turnout roadbed out of cork roadbed, it's kind of a tedious process, and I never really like it. It's always a lot of fit and fiddle and everything. And I found this adhesive-backed dense foam rubber, the exact thickness of the roadbed. So I basically cut my turnout blocks out of this for the mainline track, and I do the same thing for the yard, except I use the cork. And you can see in this graphic that I've cut out the block for a crossover that's a little bit ahead of me, right up here. And you can see the crossover switches laid down next to it because I was fitting, making sure everything was right. And you notice that I cut out the portion of this roadbed that is directly under the throw bar. I did this for a number of reasons. Number one, I'm going to have to make access for the throw bar, the actuator rod from the switch machine. And the other is I want to provide plenty of clearance because when I do ballasting, I don't want to get in a situation where stray ballast is going to get in and gum up the works. So I've got a way around that. And with that, I had to actually get ready to install the machine. Well, the first thing it is, I chucked a good half-inch bit in my Ryobi cordless drill, as you see in this picture, and I needed a good half-inch hole straight down through the sub roadbed. And you can see in this next picture, here is the hole drilled through one of the openings in the dense foam roadbed at another location on the yard. I'm putting in a tortoise switch machine, and you can see the hole goes straight through. And then on this next graphic, I've got some illustrations here to show how I set this up, because what you want to do is you want to center, you get a thing set up, the geometry, you want to center the turnout, the throw rod on the turnout, the hole in it, and it will come with a hole in them in the center of them, exactly so that there's an equal amount of force when the points are thrown to one side or another. This is not as hard as it sounds, because one of the things that Tortoise gives you, if you can see in that graphic, is a little template which shows you exactly where the rod ought to come up in the center of the turnout, where to put in the screws to hold the switch machine in. And you'll notice here the switch machine has 4 slots in it for number 4 3/4 inch pan head sheet metal screws to go on the underside of your roadbed. I use sheet metal screws are really handy for this kind of thing. And then I made a little gizmo of my own creation, a piece of music wire, straight music wire, it shows on the right side of this graphic of the coming down through wood with some tacks to hold it in position on the top of the turnout. So what I do is I position the turnout exactly where I want it. Then I run this rod down through the center of the throw rod, this music wire straight piece, while the turnout points are positioned exactly in the middle, halfway between each of the stock rails, so it's in a neutral halfway position. That protrudes underneath the layout, and that gives me something to key my Tortoise switch machine drilling template, because I can see the rod coming down through the center hole, right exactly where the actuator rod for the turnout is supposed to come up from the switch machine. And then I take, in the upper left there, you can see a punch. It's a spring-loaded punch, carpenter's punch, that I can then just put in the 4 holes for the screws and give a good shove, and it makes a divot in the underside, so my drill won't walk around, and I can drill the hole to put the screws in. And then I mount the switch machine as it shows in this next graphic. Here's the underside, here's a tortoise switch machine, all mounted in place with the actuator arm coming up through, and the next picture shows the turnout on the top side, and you can just see peeking out of the hole in the top of the center of the turnout the actuator rod from the switch machine, and it's all set to go. And the next thing I'll show you is a graphic that depicts the turnout in actual operation. Not a graphic, but a very brief clip. And you can see, as I'm throwing the switch machine one direction and the other, how realistic it looks. And the nice thing about it too is that there's enough force on the actuator arm that those points are held firmly against whichever stock rail they're supposed to be against, so you don't have any risk of derailment by a split switch, we call it. So it works really well. I mean, really, it's the first time I've used them. I've read about them a lot, and I decided when I build my model railroad, my mainline turnouts and the open scenic portion of the layout are all going to operate with these tortoise slow motion switch machines. And but this was the first place I installed it, and I'm really happy with the result. And you can see when you look in the video how realistic it looks. And with that, I'm going to reposition things and talk a little bit more about yard turnouts, and also how I did the control on these turnouts. Okay, when it comes to controlling the mainline turnouts, I elected to take a simple approach at first. Eventually, I think I would, for operation's sake, like to get into modeling remote control of turnouts by a dispatcher for the mainline turnouts, and I will use an application on my laptop over on this side underneath the layout to do some of that. So I'll have a running position of a dispatcher when we have a crew to operate the layout. But there will be times when I want to run the layout just myself, just for fun. I mean, just to run trains, to see trains run. So I want to retain some control of the turnouts at the location rather than having to run back over the computer to throw a turnout. To start with, though, I don't have the computer system set up, so I'm going with local control, which means that the double pull, double throw toggle switches I'm using to switch the polarity on the turnout motors have to be accessible. Now, double pull, double throw switches and turnouts. Let me explain something a little bit here. The tortoise switch machines have positive, negative contacts on the bottom, and the way you reverse them, throw them there, is you reverse the polarity of the current coming into them. So they run the other direction. They're on DC. They're not AC. So you have to reverse the polarity. And the way you do that is you run the common leads, the center leads of the double pull, double throw switches to the turnout motor. And then on the two sides, the pole sides of the toggle switch, you have the polarities reversed, so that when the switch is thrown in one direction, the polarity is set up one way and the switch motor moves one direction. When you throw it the other way, it moves back the other position. So I have these miniature toggle switches, and when I first put them in, I was showing a graphic here before I wanted to make sure everything was working right before I did any final stuff. I just took about 4-inch squares of masonite and drilled a 1/4-inch hole through the middle of them, and just screwed them to the edge of the bench work, and had the toggle switch in there and made sure that everything was working the way I wanted it to. But that wasn't going to be the final solution. That was just an expeditious way to do things to get through that phase of it. Because, as you see here, this is the first place on the layout where I'm doing this. I'm putting on a fascia strip to dress up the layout a little bit. And this is 3/16 inch tempered hardboard masonite that I'm securing with self-drilling screws to the edge of the bench work. And eventually I may paint this, but the basic color of the masonite looks pretty good, so I I may leave it the way it is. Between the 8-foot sections of this, I covered the joints with some vinyl joint strip that fits right in there against it and kind of dresses it up a little bit. So it makes a handier work surface. But the problem is, if I had had these switches directly mounted in the fascia board, they'd be sticking out. And that's kind of an invitation for them to get whacked by things. And so what I wanted to do is to recess them in. And I thought about it for a while, how I want to do it. And then a thought came up in my mind. I said, why don't I drill 2-inch holes, and if anybody recognizes what this is in your modern day cubicle offices, this is called a desk grommet. Okay, and normally you'll have a couple of these in the top of your work surface in your cubicle desk. You live in cubicle land like Dilbert and I did for most of our career. These will be located through the back, and they run all your computer and electrical cables through them, so they're not flopping all over the place. It's a way to organize stuff. And I got a dozen or more of these at Amazon for like $4, $5, and they're a hard plastic, and they come with the cover plate, which I'm really not going to use because I wanted this part. And as it shows on the graphic, this next graphic here, I got a 2-inch, 2¼ inch hole saw for my Ryobi, which just happens to have a pilot drill. It's a 1/4 inch. And which is exactly what I need for the toggle switches. So everywhere I wanted the toggle switch to be positioned on the fascia, I drilled in with the hole saw, and what that gave me is a hole that just perfectly fit the flange on these desk grommets. This would just come in and pop right in there. And it also gave me a piece of masonite exactly sized to fit inside the hole grommet. And then I said, well, I'm going to need to reinforce this a little bit. So I looked around and I found that these party beer cups, solo beer cups you get at the supermarket, a package of 50 for a few bucks. The bottom, if I cut it out, fit precisely around this part of the hole grommet. So then if I cut out the middle, okay, and left that open, and then took the donut hole that I got out of the hole saw from drilling through the masonite and popped that in here, and used some good old liquid nails to glue this to the hole grommet and the back of the masonite, which already had a 1/4 inch hole in it, and this center portion of this is cut out. I could just pop this in and run the toggle switch through there and tighten down the nut, and now I've got a nice recessed, you can see right here, the switch is not sticking out where people are going to bump into it. It's got a nice recessed cover. It dresses it up pretty nice, leaves it nice and clean, and removes a bumping and damage hazard. Now, to move on a little more about the turnouts in the yard. As I mentioned, they're manually thrown, and there's a number of ways you can do this in a model railroad. You can get ground throws. The problem is the HO scale ground throws for these turnouts they're way oversized, okay? But I found a way, an article in Model Railroad Hobbyist magazine, of if I very carefully position them, I can use N scale ground throws, and I'm going to put a graphic in here that actually shows the ground throw. And I can use N scale ground throws, and they have just enough travel to reliably throw the switch to each side, and they look more realistic. And I can slide them in under the head block ties so that they even makes them look a little smaller, so they'll be less obvious. So they're not quite scale size, but they work. Now this is for turnouts that do not have sprung points. There's other turnouts I have here, like these turnouts by Micro Engineering, and this is a Pico curved turnout over here. They use what's called an over center spring on their points, which means that it provides tension to hold the points in one side or another. If you're not using a switch machine, you can basically just use these turnouts and with your finger just shift the switch points and they'll stay exactly where you want them. And that's fine, and I have a number of these turnouts and I'm going to be using them, but I also have a great number of these number 6 Atlas Code 83 turnouts, and what I did is I essentially tore apart a Pico turnout and saw how they did it with an over center spring, and using 028 music wire, very fine music wire that's very stiff, and it makes a good spring. I basically bent an L-shape spring with prongs as an over-center spring, and I've got some graphics here to show what it looks like, and I mounting that in the ties and the throw rod for the Atlas number 6 switches. I'm going to use that in some other places to emulate a manually thrown switch, and so it's a little different approach. I'm trying some different things, but in all the cases, one of the things I want to do eventually to dress everything up is I'm going to equip all these spring-loaded switches with a dummy model ground throw next to it to make it look realistic. But that's down the road a little bit. And so that's how I'm doing the switches in the yards. And again, they'll be manually thrown because your yard crews will be running trains. You'll have a brakeman and engineer that you're doing yard switching, and they'll be throwing the turnouts manually. And the same for the industrial switching and the branch line switches. So with that, I'm going to get busy, do some other things, and talk a little later about the backdrop, and that should wrap up this episode. Okay, to pick up on the last segment on this episode, I want to talk about the backdrop. And the backdrop is important because it gives the suggestion that there's a world beyond the 2-foot wide shelf that is most of this railroad. And the backdrop for me is the biggest challenge and difficulty because try as I might, and I've read all the books about doing it and techniques and everything, is that I'm just not very good at doing backdrop artistry to suggest land. And I can do sky. I mean, sky is pretty easy. You get a primary blue for the darkest part of the sky and a white, and then you blend them. You put the blue in the top half and the white on the bottom, and then you kind of dry brush them together, and you get the effect that you see here, which suggests the high stratus clouds, which are most common over the part of country that I'm modeling, the Central Valley of California, where you don't really get a lot of the big puffy clouds unless there's a thunderstorm coming through. So it's usually pretty sunny days with at the most high thin ice clouds, and only that seasonally. So that part I could do, but the hills, mountains, that kind of stuff, try as I might, I'm just not good at it. I can't seem to get it, and it looks very amateurish. So I was struggling with how to do this, and I have to mention our son-in-law Kirk is a very good artist, but I mean, there's like 120 feet of backdrop on this layout, and that's not a painting job I would put on anyone, myself or anyone else, particularly a young father like him with other responsibilities. So, I figured to wrestle with how am I going to do the backdrop. And then I had a bit of a brainstorm. I've got a very nice color laser printer upstairs in my office. And I started looking online at Google and others for publicly available, publicly releasable, usable images. And I basically searched on keyword phrases like Central California, California hills, high desert, whatever, and set the search parameters so that I would get the largest images, because I was looking at getting large expanses and also high dots per inch for quality of reproduction. And there were hundreds. So I was like, okay, well, there's something here I can work with. And I downloaded them, and using a combination of Adobe Photoshop, which I can generally muddle my way through, or the standard paint shop function that's in your basic Windows installation, I downloaded them and was able to crop them, and because they were so large, I could turn them into panoramic shots, which they did. A lot of them were panoramic to begin with. And rendered at 1-to-1 scale from the image, some of these panoramic segments were as much as 20 feet long, which is, hey, great. And what you see behind you here is one of those segments. This is one entire segment, and on the layout it stretches for just over 20 feet. And then what I did is mirror image reversed it and continued it again another 20 feet. So this is the entire backdrop for the Warrenville, all the way from a tunnel that's going to be on the far east end of town all the way around through to a tunnel that's going to be way over here in this turn-back curve. And what I did is, this is an example here. This is one where there's a panel of 7, and I printed it out on my laser printer. And for distant backdrop, these are going to look fine. And then you can see there's an overlap here, how they join up. And this is another segment of backdrop. This one of 7 panel series is going to go over in that area, and then I'll pick up with others. It becomes progressively more mountainous. And I apply it with pre-mixed wallpaper paste that I get at Home Depot. I basically cut these out, cut out the top edge with a very sharp razor knife, cut out all the sky feature, and wallpaper them up onto the masonite backboard. And you can see the net result here. The only thing that I have to do yet, and Kirk is going to say he's going to help me with this, is that there are some slight gaps that are visible at some places. You really can't even see it from the video here, but I can see it close up, and I know they're there. And that just requires a minor amount of touch-up. And Kirk said that should be a pretty straightforward, easy thing to do with pastels or some other media that will cover it up. And now you're asking, okay, well, what about this area down below here? Well, there's going to be some foreground scenery and some low relief structures and vegetation and this kind of stuff. So you will never see this white area. It'll just look like a near far object. And then beyond that is the vista of the mountains and hills. And as we go on around further east on the layout, it's going to become more arid. The California hills are going to be the brown hills in California that you see much of the year. In this area, this is somewhat higher elevation. They're still green, and it'll provide a nice backdrop for the layout. Convincing enough to say, okay, there's a real world that this layout is running through, and not just a shelf somewhere. So that's my quick and dirty way to do a backdrop.